So welcome everyone. In this video, today we are going to solve the 2023 chemical engineering fluid mechanics question. Okay, so let's start the question. Okay, we move on to the first question. So in the first question, for a alphabet comprising of a uniform size spherical particle of diameter dp, and the pressure drop across the bed is given by Cushman normal distribution. Okay, so the normal bed contains diameter of particle dp. Okay, its pressure across the bed is given by Cushman normal distribution. Okay, it's not a problem. Then the particle Reynolds number is less than 1. Okay, correct. When we apply the Cushman normal equation, it is applicable to the Reynolds number less than 1 under these conditions. Minimum fluidization velocity is proportional to d to power n. One of the following is correct value of exponent n. Okay, now we go on to solve the problem. Okay, so let's write down the given data. Okay. So find the limit. So the particle diameter is given by d2. Okay, so it's applicable for this condition. Condition Reynolds of particle is less than 1. Then we apply Coordinate carbon equation. Okay, coordinate carbon equation. And what we need to find at minimum fluorization. At minimum fluorization, the velocity is proportional to d2 power n. At minimum fluorization, the another condition is now that is condition is given. Next is for coordinate carbon equation. Second condition for minimum fluorization velocity. So what is mean by it is the minimum velocity is required to fluorize the particle in the alphabet. That's it. We need some minimum velocity. That's the threshold velocity. After that, only the particle moves. Before the fluorization velocity, the particle won't move in the flow packed bed. Okay. So there are two conditions given. One is for a Kuznets Garment equation. Another one is for a minimum fluorization velocity. Okay, so then what we can find the relation between the velocity and the dp power n. So we can calculate what is the n value. Okay, now the question is over. Okay, now you understand. Now explain the two conditions. We will solve the problem. Okay, so now move on to the first condition. What is first condition is given? Gaussian-Forman equation. So what is the equation? It is a very important formula you need to remember. Del P by L is equal to 150 mu. Then V, V is for velocity and 1 minus epsilon is whole square porosity and phi s density dp is whole square diameter of the particle and epsilon cube porosity. It is very important formula. It is applicable for next condition. Reynolds of particles is less than 1. It is also very important. Now, the minimum fluorization velocity condition. Okay? Now, minimum fluorization velocity. So what is that formula? Del T by N is equal to V into rho P minus rho F. Rho P minus rho F means density of the particle and density of the fluid into 1 minus epsilon. It's a white space, available white space. Okay? Okay. Now, we see here, here and here. Here, del P by L. Here also del P by L. So, both LHS and RHS are equal. Okay? So, both LHS and RHS are equal. So, think LHS is equal to RHS. Okay, so what will you get? 150 mu v 1 minus epsilon the whole square by s dt is square into epsilon cube is equal to v into rho p minus rho f into 1 minus epsilon. Now, go to the question again. So, what do we need? We need relation between v and dp. Okay. So, let's observe the relation between v and dp. So, v, v is here and dp also here. So what happened? V directly proportional to dp power n. Okay, this is the relation. It is the relation. Mhm. So what is n? N represents here. It is the 2. So what is the value of n? It is the 2. Yes, simple. So what we do? We use the condition. Condition is Courtney-Garman condition, and another condition is the minimum polarization velocity. Then relating to the velocity and the particle diameter. They get the n value. That's it. Okay. Move on to the second question. So, which one of the following quantities of flowing fluid is measured using a rotameter? Okay. So basically, a rotameter is used for measuring which one? Static pressure, dynamic pressure, volumetric flow rate, viscosity. We all know that it is obviously volumetric flow rate. Okay. So rotameter, orifice meter, weight meter, we measure your volumetric flow rate along the pipe. Okay. Okay. So move on to the next question. So third question. So the given question is the viscosity of an incompressible Newtonian fluid is measured using a capillary tube of diameter 0.5 mm and length 1.5 meter. Okay. The fluid flow is laminar, steady, and fully developed. So for a flow rate of 1 centimeter cube per second inverse, the pressure drop across the length of the tube is 1 megapascal. So the viscosity of the fluid is 2 into the power minus 3 Pascal second. Then the value of K is okay. So in this question, we need to analyze the question itself. So it mentioned incompressible Newtonian fluid. Then the fluid is laminar, steady, and fully developed. So these are the assumptions used for where these are the assumptions used here. So suddenly we come across the formula is which formula? Again causally for formula del P is equal to square root mu V L divided by D square. Okay. Okay. So now we know del P value, mu value we need to find velocity is given in terms of volumetric flow rate. L length is given and particular diameter of the tube also given. Okay, it's easy to calculate. Okay, now solve the problem. Okay, let's convert the all the unit in. Let's convert all in same unit. First, the given data. So given data. So diameter is equal to 0.0005 meter. Length is equal to 1.5 meter. And del P is given by 1 megapascal. How it convert? With 1 into 10 to the power 6 pascal. Okay. Then Q is given how much? 1 centimeter cube per second. When we convert it to the meter cube per second, this 1 centimeter cube is equal to 10 to the power minus 6 meter cube. That's it. So 10 to the power minus 6 meter cube per second. Okay. Okay. So we instead of calculating Q from V from Q, we can directly go to the Higgins-Pascal formula in terms of flow rate. What is that? 128 mu Q L 5D power 4. That's it. Okay. What we need? We need viscosity. So write in terms of viscosity. So mu is equal to del P pi d to the power 4 and 128 into Q into L. So apply all the value. So del P value is 10 to the power 6, pi is 3.14, d is 0.0005 into 10 0.5 power 4 divided by 128 into Q value is around 10 power minus 6, L is 1.5. So calculate in terms of 10 to the power minus 3, because in a given question they asked in A in 10 to the power minus 3 partial integration. So how much they will come? It will come around 1.023. Okay. So the correct answer is mu 1.023 into 10 to the power minus 3 Pascal second. Okay.